4.6 isosceles, equilateral, and right triangles. Back in 4.1, we already talked a little bit about isosceles and right triangles. Then we talked about legs and hypotenuse and base. And with an isosceles triangle, the legs are the two congruent pieces. The base is the third side. So these are congruent to each other. And now remember, we could spin this upside down and the base could technically be on the tops. The vertex angle is between the two congruent sides, and our base angles are opposite. Let's go my base angles. Do this. Oh, can't do that. There you go. Base angles are these two down here. Okay, they're opposite the legs. Vertex angles, my third angle, then opposite base. Okay, now here's a quick question for you. What do we know about base angles of an isosceles triangle? And here we just dropped an altitude down from the vertex angle, and at this point, let me think of my proof, but this side is congruent to itself, and we have a right angle. So since this is a right angle, I guess this is my proof. There's probably a bunch of different proofs, but from what we know right now, this side and this side are the same, and it's a right triangle. You could use the Pythagorean theorem to find this side, right, with using these numbers, and then you could do the same thing and use the Pythagorean theorem to show that this side is actually congruent to that side. And then these triangles are congruent by side, side, side. So what do we know about the base angles? Once we show that these two triangles are congruent, our base angles have to be congruent by CP/CT. That brings us to the base angle theorem. If two sides of a triangle are congruent, meaning it's isosceles, right, then the angles opposite them are congruent. So for an isosceles triangle, the base angles are congruent. The converse is if two angles of a triangle are congruent, then the sides opposite them are congruent. So remember, converse, you flip the hypothesis and conclusion. For equilateral triangles, remember, equilateral triangle is just a special type of isosceles triangle. We know that this side is congruent to that side. So the base angle theorem would say this angle is congruent to that one. We also know this side is congruent to this side, so these are also technically base angles that would be congruent. And for an equilateral triangle, it turns out that it is also going to be equal angular. Okay, all angles the same measure. Okay, corollary, remember, it follows easy from the theorem. And the corollary to the converse is if all the angles are the same, then it's an equilateral triangle. Okay, on a side note, remember the triangle sum theorem says the sum of all these angles is 180. So I could say x plus x plus x equals 180. It's helpful to know that the measure of an angle in an equilateral triangle is going to be divided by 3, 60 degrees. Okay, useful fact, and it'll come in handy in problems like this. Okay, so find the values of x and y. We have an equilateral triangle here, right? These marks show the sides are the same, and we just showed that these angles are all 60. Okay, so x is 60 degrees. And now we need to figure out what y is. How do we do that? Well, from here, if this is a 60-degree angle, this angle and that angle have to add up to 180. So 60 minus 80, this angle is a 120-degree angle. If that's a 120-degree angle, I know this is also an isosceles triangle, highlighted in purple here. This is also an isosceles triangle. So this one was equilateral, this one's isosceles, and I know in an isosceles triangle my base angles are congruent. So if this angle is y, that angle is y. So I could say 2y plus 120 equals 180. 2y would have to equal 60. Subtracting 120 from both sides, divide by 2, y equals 30. So those are my two answers. Y is 30, x is 60. And these are the things. Third angles theorem could be helpful. You know, the linear pair postulate. Here's the last way we're going to talk about proving triangles congruent. I think there's a couple other ones, but they're just not very common or useful. But the hypotenuse leg theorem, we call it the HL congruence theorem, says if you have a hypotenuse, remember that's opposite of the right angle. If you have a hypotenuse and a leg of a right triangle, so notice it has to be a right triangle. So really I have an angle and two sides. And we talked about the donkey postulate doesn't work, but if it's a right angle, that donkey postulate will work, and we'll call it the hypotenuse leg theorem. Okay. And so I got a handful of these problems where you have to tell if the triangles are congruent and why. So we start with the first one. Are these triangles congruent? I only know two sides, right? So not enough information. No, we can figure out that this side is congruent to itself by the reflexive property. So yes, these are congruent by side congruence postulate. Over here, I know this side is congruent to itself by the reflexive property. And now I know two angles and a side. That should be enough information. The side is not between the two angles, right? And same thing here. So this would be angle, side. The side is not included between the two. Angle, side, congruence postulate. Next one, once again, reflexive property, right? Kind of a common theme on these first four, it looks like. But this side is congruent to itself, side, angle between the two sides, right? So the angle is included between the two sides. That's side, angle, side, congruence postulate. Here, reflexive property says this side is congruent to itself. Is that enough information? It looks like I have an angle, side, donkey postulate, right? Well, almost, except for since it's a right angle, we get to use our new theorem. This is a hypotenuse, and this is a leg, right? Here's my leg. There is a hypotenuse. So with a right triangle, we can do one other thing. We can use the hypotenuse leg congruence. It's theorem, right? Just double checking. Yep, theorem. And two more. Good. All right, we got some different ones in here. How are these related? Mark the side that you're given. Looks like I have an angle, side as my side is not between them. Angle, angle, side, congruence postulate. Okay. Here we have a side. This side is congruent to itself by the reflexive property. And a right angle. So that would be, remember right angle, we can also use the hypotenuse leg theorem, right? Hypotenuse leg congruence theorem. And two left. This one's a little bit different. We don't know this side. They don't share a side, so we can't use that reflexive property. We know two things. But we also know that this angle is congruent to that angle by the vertical angle theorem. So I have an angle between the two sides. So side, angle, side congruence postulate. Oh, you know what? I was just thinking. Angle, angle, side was a theorem. Not a big deal. I wouldn't mark that wrong or anything, but might as well make this right. And the last one, vertical angles say this angle is congruent to this angle. So I have angle, side, angle. The side is between the two angles, so it goes there. Congruence postulate. There's your homework. I'll see you in class.